All right, when we left off, we were taking a look at this assignment right here. This is the second page of Simplifying Radical Expressions, Part 1. We're going to obviously have a couple days on radicals, so we're going to have a Part 2 coming up pretty soon here. So in these problems here, we're going to simplify these radical expressions. Radical, again, is anything that has a square root symbol. But the method we're going to use is called factoring. All right, so you can punch the square root of 48 in your calculator and it will simplify it for you. But I actually want to see how you're factoring this. And so how you're going to show your work and how you're going to get credit for this assignment is to actually show me the factoring, because we have a whole unit on what we call factoring polynomials, which is a little harder than factoring numbers, of course, but it's the similar concept. So getting used to breaking things down and knowing what that means and all that kind of stuff is going to be really good for you, even though it might take a little bit of extra time. So let's take a look at a couple of these. All right. Now, first off, we got to know what the index number is. The index number is like this 3 here, this 4 here, and it tells us what powers that the root can undo. So if you don't see that number, you can just assume it's a 2, right? Or in other words, that square root's going to undo squares. And then we're going to kind of factor the numerator. So there's lots of different ways to factor. You can break it down however you want. I'll show you a couple different ways. The first way is just to prime factor. Okay, so prime factor is break it all the way down into its pieces. So I'm going to take 48 and I'm going to break it down. Now there's lots of ways to break down 48. I'm just going to do 6 times 8. It doesn't really matter where you start. You're going to end up with all the same prime factors at the end anyway. So we got 6 times 8, and 6 is 3 times 2, 8 is 4 times 2, and then, sorry, I should have written a little smaller. I have 2 times 2 there. So 48 is, we got 2 and 2 and 2 and 2 and 3. So it's 2 to the 4th times 3 to the 1, and then we have a k to the 3rd in there as well. Okay, so that's kind of what we have going on under the square root. Now, again, the index is 2, and so what we want is we want powers of 2. We want to be able to cancel any powers of 2 that we see in here with that power. So what I would probably do in this case is factor this guy and break it up into pieces. So 2 to the 4th is the same as 2 squared times 2 squared. I got a 3 to the 1. Okay. Also, I have the k to the 3rd, I can write as k squared times a k to the 1. And I'm looking for those powers of 2, right? There's a power of 2 here and here and here. I'm looking for exponents that are 2's, because this root cancels that power, right? So from here, there's a couple different ways to do it. The longer way is just to write out everything as like a separate square root. So square root of 2 squared, square root of 2 squared, square root of 3 to the 1 power, square root of k squared, square root of k to the 1 power, right? And we know again that these are all index 2 or the 2 root. So the square root and the square cancel and I just get a regular 2. The square root and the square cancel, I get another regular 2. Now here I don't have a power of 2, so I can't cancel the square root. Okay, here the square root and the square cancel and I just get a k to the 1. And then here I can't cancel either, so square root of k to the 1. So what the things where the square root canceled were is a 2 and a 2 and a k. So that's 2 times 2 is 4, that's 4k. What was left under the radical is a 3 to the 1 and a k to the 1. And so I'm going to put those back under the radical as 3 times k. It's 3 to the 1 times k to the 1. All right, and there you go. That's a k, by the way. So that's how you can factor it. That's not the only way to factor it. That's just one of the ways to factor it. Okay, so let me give you another example of what you could do. Okay, so let's say you're going back here, and you got the square root of 48k to the 3rd. Just kind of do an alternate method. And this is, if you want to do it this way, you can. If you know your perfect squares pretty well, and you know your multiplication tables pretty well, sometimes you can pick like the biggest square factor that goes in here. Like, what are our perfect squares? 1 squared is 1, and 2 squared is 4, and 3 squared is 9, and 4 squared is 16, right? Those are all the perfect squares. So the question is there any of these numbers, these special squared numbers, that goes into 48? Well, it just so happens that 48 is 16 times 3. So I could do, this is the square root of 16 times 3 times k squared times k. And then anything that I can take the square root of, I just take the square root of. So square root of 16 is 4, square root of k squared is k. What I can't take the square root of is 3, and what I can't take the square root of is this k. So kind of a faster way of getting there, but you have to kind of know your perfect squares and what perfect square factors go into that number. And sometimes you just don't know that. Right? So if you look at, let's pick another one here, like 18 for example. And you're like, what perfect squares goes into 96? I don't know. So you can prime factor it and find out for sure. You can also just start practicing and just see what happens. So 96, does it divide by 16? Okay, it does, right? Or you could do like, does 96, does 4 go into it? I'm just dividing it by perfect squares, right? And my perfect squares again are 1, 4, 9, 16, 25. My next one would be 36. Or 49. So if I can find one of those numbers that goes into that number, then I can simplify it a little easier. 96 divided by 49, for example. Okay, that doesn't work. 96 divided by 36. Okay, that doesn't work. 96 divided by 16. Okay, that's the one that worked, right? So if I wanted to factor this guy, I could say, oh, okay, that's just the square root of 16 times 6. And since 16 is something I can take the square root of, I can just bring it a 4 from this point. Okay, that's one way to do it. So let's go back and prime factor it and kind of go from there. So 96, I'm not sure what goes into it, but 2 definitely. I don't know all the other numbers that go into it, but definitely 2. And so if I divide 96 by 2, that's a 48, which is 6 times 8, which is 3 times 2. And then 8 is 4 times 2. And then that 4 is a 2 times 2. Okay, so I have a 2, a 2, a 2, a 2. I have 5 2s and a 3. So 96 is 2 to the 5th times 3 to the 1. So kind of similar to the previous one we did here. And then I have, of course, the a to the 1 and the b to the 2. All right, so that's one way to do it. And if you don't know, like if you couldn't look at 96 and be like, oh, 16 goes into that, which I couldn't, this is one way to get there. Okay, so from here, we're looking for powers of 2 if we can get them. So I have a 2 squared and another 2 squared, that's 2 to the 4th, and then another 2 to the 1. So altogether, 2 plus 2 plus 2 is 5. All right, now if you think about it, this is a 4 and this is a 4. Or in other words, this whole thing together is a 16. So now you're like, you can see that it's like 16 times 2 times 3. Then we need another 3 in there. Okay. And then we have a to the 1 and b to the 2. Right? So we're looking for powers of 2 because the index on this root is 2. The root cancels powers of 2. So this root 2 cancels with this power of 2, leaving me a regular 2 on the outside. This root 2 cancels with this root 2, this root 2 cancels with this power of 2, leaving me with a plain 2 on the outside. Nothing can happen here though, so because we're looking at the powers. So inside, I still have a 2 to the 1. I also still have a 3 to the 1, and I also have an a to the 1. But this 2 can cancel with this 2, and I'll have a b on the outside. All right, so if we see something with a power of 2, like this b or like this 2 or like this 2, we can actually cancel that power and put it on the outside so that it's, cancel the power and the root at the same time. So this is 4b times the square root of 6a. You can put 6a to the 1, but we don't really need that 1 anymore. All right, so that's what we get there. Okay. Now up here, I actually took that root and I split it into lots of different tiny roots. Conceptually, that's what's happening. That's the property of radicals that we're applying. We can think of these as all individual roots. Now over here, I didn't write that whole step out, but You can if you want to. It's a little bit more writing. But at this point, I'm just looking for my powers of 2, and I'll think in my mind, okay, those two powers, that root and that power are going to cancel. It gives me a 2. That root and that power are going to cancel. It gives me a 2. That root and that power are going to cancel. It gives me a b. And then just leave everything else. All right, let's do a higher power. Do you believe in a higher power? Just kidding. That was a bad math joke. All right, so let's take this guy. Now, again, what the idea here is we're looking for powers of 3, right? We want to cancel powers of 3. The third root will cancel powers of 3. But we don't know if we have any powers of 3 until we start factoring. So 625, I'm pretty sure that's divisible by 5. So let's see what that is. I think it's 125, but we'll see. Yep, 125. Okay. And then that is also divisible by 5. That is 5 times 25. And then that is also divisible by 5. 5 and 5. So altogether I have 5, 5, 5, 5. I have 5 to the 4th power here. So I have the third root of 5 to the 4 x to the 1. And remember, I'm looking for powers of 3. Right? The root cancels powers of 3. They undo each other. So what I can do is I can rewrite this as 5 to the 3rd times 5 to the 1, since 3 plus 1 is 4, times x to the 1. Okay? Now this power of 3 will be canceled by this root 3, which is going to leave me with just a regular 5. And so I put that on the outside. I can't do the same thing with these two, though, because this is not a power of 3 and neither is this. So what's stuck inside that third root is a 5 and an x. Okay. Now in the directions here, just to clarify, it says show how you are factoring the radicand. So if you were to get to right here, you know, that shows me the factoring. You don't have to do the tree necessarily. Another way you could have done it is say this is the third root of 125 times 5 if you knew that 125 was 5 to the 3rd power. Right? And then you could just be like, okay, that is 5. Third root of 125 is 5. But then I still have a 5 and an x stuck in there. So either way, you're good. But what I'm trying to get you to do is to just not use your calculator to just plug it in and just have it spit something out. Just to actually see the factors and see how this is working. All right, let's do a 4th power. Actually, let's do another 3rd power and then we'll do a 4th power. Let's do 22. Okay? So let's factor 64. Okay, it's 8 times 8. It's one way to break it up. Now each of these are actually 2 to the 3rd power. So, you know, if you're like, oh, the third root of 8 is 2, you can do it that way. But we got 4 and 2 and 4 and 2, and then 2 and 2, and then 2 and 2. So 1, 2, 3, 4, 5, 6. So we have the third root of 2 to the 6th, x to the 4th, y to the 4th. But we want powers of 3 because this root 3 will undo powers of 3. So we're trying to get powers of 3. So I can do 2 to the 3 times 2 to the 3. That's 2 to the 6th. That's cool. And then I have x to the 3 times x to the 1. 3 plus 1 is 4. So just splitting up those x's there. And then I'm also going to split up the y's. So y to the 3rd times y to the 1. Okay, now again, I could write all of these different factors as separate third roots like I did up here, but that gets kind of annoying. That gets kind of tedious to write all that stuff. So what we know is once we have powers of 3, anything that has a power of 3 is going to cancel with that root. So this 3 cancels with that root, giving me just a plain 2. And this 3 cancels with that root, giving me another plain 2, but we're multiplying them. As they come out of the root, they're multiplying each other. And then this 3 and this 3 undo each other, giving me just a plain old x. And then this 3 and this 3 undo each other, giving me just a plain old y. What I can't do is I can't do the x to the 1, right, because I need a power of 3, and I can't do a y to the 1 because I need a power of 3, and I don't have enough pieces. So what's left is a 4xy and the third root of xy. Now you may, I don't know if you've heard this analogy, but sometimes a teacher will teach you this analogy with like a jail or something like that. And they'll say like this route is like a prison, like a jail, and you can only get out of the jail if you have a power that's this number. So there's, 2 to the 3rd power, and that can get out of the jail, and this can get out of the jail, and this can, but these guys stay stuck in the jail. So you may have heard something like that, but the x and y, x to the 1, y to the 1 are kind of stuck here, stuck in jail because they don't have a 3rd power. All right, let's do something with the 4th power here. We'll do number 23. All right, so again, we're going to prime factor. Now, once you do these a bunch of times, you might kind of get the hang of it. Like, I think we've probably seen 64 before. Actually, yeah, we just did 64 up here. We already prime factored it. So you can reuse that prime factoring. We already know it's 2 to the 6th. 1, 2, 3, 4, 5, 6. So you could do that. You don't have to redo the factoring. Actually, let's go back and do 21 instead because we've already done something with the 64. All right, so 48. That's 6 times 8. And 6 is 3 times 2. And 8 is 4 times 2. Oops, sorry, 4 is not prime. I shouldn't have circled it. And that's a 2 and a 2. So we're only going to circle the primes, the bottom of the branches, basically. So 2 times 2 times 2 times 2 times 3. 16 times 3, or 2 to the 4th times 3. So I have the 4th root of 2 to the 4th times 3 to the 1 times v to the 8th. Okay, now remember, I'm looking for powers of 4 this time. So if you want to use that jail analogy, if that's something that's familiar to you, only people that can get out of jail are the guys that have powers of 4. So I have 2 to the 4th already. That's cool. I have 3 to the 1, and I can take this v to the 8th and make it a v to the 4th times v to the 4th, just kind of manipulating that, breaking it apart into pieces. So now anything that has a power of 4 can get out of jail, basically. So the 4 and the 4 are going to undo each other. We get just a regular 2 on the outside. This 4 and this 4 undo each other, which gives us a v on the outside. This 4 and this 4 undo each other, which gives us a v on the outside. Now remember, we're multiplying. That's really what's happening here. So 2 times v times v. And then what's left over is the 3 to the 1, and it's a 4th root of 3 to the 1, and we can't do anything. So we have 2 times v, or 2v squared, times the 4th root of 3. Okay. Now going back to what I said just a minute ago, when the things get out of the jail, they're multiplying, it's kind of hard to see that if you don't understand that really this is what's happening, right? So when you have that big long root and then you break it up into different pieces, what's really happening is you have a root with all these factors, and you're changing that the root of factors to, or the root of a product to the product of roots. And that's a property of exponents, or excuse me, a property of radicals that we talked about today. So let's just go back and take a deeper look at this one really quick, just in case you're wondering what's happening here. So if I had the 4th root of 2 to the 4 times 3 to the 1 times v to the 4 times v to the 4, what's actually happening here is that this is like a product, right? It's a bunch of things getting multiplied. We call that a product. So the root of a product is the same thing as the product of the roots. So what I'm going to do now is I'm going to take the 4th root of everything individually. We did this at the first problem we did on this page. We did it this way. Sorry, that's a 4. That's a 4. Right. So each factor of that product is going to get that, we're going to be taking the root of 4. And notice that these are all getting multiplied, so the final roots are going to get multiplied. That's very similar to a power of exponents that we talked about called the power of a product. Well, this is just the root of a product. It's kind of the same idea. So if we have the root of a product, then we're just going to multiply, and we're going to have the product of all the individual roots. Everything will get that 4th root. Okay, now it's easier to see what's happening here. Right, that's just a regular 2, the 4th power and the 4th root canceling. This guy can't change at all. Here we get canceling, that's a v. Here we get canceling, and that's a v. But notice that everything is getting multiplied. And so we can use the commutative property to rearrange it. And then we can, kind of simplify. Since that's v squared, we got 2v squared, 4 through to 3. Okay, so sometimes just memorizing like a method it can be helpful, but it can be limited as well. So when you're looking at this and you're like, well, what happens with the 2 and the v and the v? Like when I take out the 2 and I take out the v, are they adding? Are they going to multiply each other? They're actually multiplying each other, and it all comes back to this property here. When we break this root up into pieces, all of those pieces are multiplying each other. And when some of those pieces simplify, they're still multiplying each other in the final answer. Okay, let's do one more just for fun, okay? Just one more example, okay? I went a little too far down here, so I'm going to erase that just a bit so you can see. Let's take this 108 and let's prime factor it. Now, you might be able to just take your calculator and start dividing it and see what it goes into. That's like one option. So I would say this for sure is divisible by 2. Okay, maybe it's divisible by 4. Maybe it's divisible by 16. So you might try dividing it by some of the perfect squares, like 4 or 9 or 25 or 36, and just see what happens. But in this case, I think I'm just going to divide by 2. Okay, so that's 2 times 54. All right, and 54 I know is 9 times 6. And 9 is 3 times 3. And 6 is 3 times 2. So I got a 2 and a 2 and a 3 and a 3 and a 3. And you might be wondering, like, why is it always 2s and 3s? Well, that's a good question. It's a lot of times 2s and 3s and 5s. The reason why is if you have a factor of like 11, then these numbers get really big really fast. So a lot of the numbers that the worksheet has here are the reason why they factor out to 2s and 3s and stuff like that is because those are lower prime numbers. And if you have 17 is a prime number as well, but if you have like 17 to the third, for example, that's a really, really big number. So anyway, we got the third root of, we got 2 squared and 3 to the third. Okay, now we're looking for those third powers, so that's good. Right off the bat here, let's see, let me just rewrite that so it's a little nicer. So 2 to the 2 and 3 to the 3. And then I'm just going to go ahead and do a to the 3 times a to the 3. I'm just going to keep doing a's to the 3 until I run out of a's. I have 7 of them. Well, there's 6. All right, so I need one more. And b to the 7th, same thing. I'm looking for powers of 3. So let's do b to the 3rd. Let's do another b to the 3rd. And then let's do a b to the 1. All right, so this third root is going to cancel anything that has a power of 3. Or it's not going to cancel the whole piece. It's just going to cancel the power. So this third root will cancel with the powers that are 3 and leave the rest of the stuff. Again, going back to what we just talked about, we could break our root up into tons of little pieces, but notice there's 1, 2, 3, 4, 5, 6, 7, 8 pieces here. And so we'd have to have 8 square root symbols, and that's going to get kind of messy. So this root 3 is going to cancel with this 3, giving me that regular number 3 out front. This 3 is going to cancel with this 3, giving me an a out front. This 3 is going to cancel with this 3. Let's mark them off as I go. Which is going to give me another a out front. And again, these are going to multiply each other. This 3 is going to cancel with this 3, giving me a b out front. This 3 is going to cancel with this 3, giving me another b out front. And that's all I can do. What's left was the 2 squared, which we can write as 4 now. We had an a to the 1 that didn't do anything. Mark those off. And then we had a b to the 1. All right, so now that we have these outside, we have a 3a squared, we got a b squared, we got the third root, and we got a 4, an a, and a b. All right, so yeah, show me the factoring. Show me what you're doing. Show me how you're factoring it. That's how you're going to show your work here. So we did several of these. 1, 2, 3, 4, 5, 6. 6 of them. So that's about half on this page, so that should help you out. You also have the answer key, so really, really important when you're going through your homework. Make sure you're checking your answers. Sometimes I will give you all of them. Sometimes I will give you some of them. It kind of just depends on how much work you can show. If there's not a lot of work to show, then I probably won't give you all the answers. If there's a lot of work to show, then I'll probably give you the answers because you're not going to get credit if you don't show your work. But super important to be checking your answers so that you know what you're doing wrong. It's all about self-assessment, asking yourself the question, could I do this on a test or quiz on my own? And if the answer is no, then you need to keep studying and keep practicing. And you know, the only way you'll know that if you're getting it is to check your answers. So do that assignment, finish that assignment, but remember, if you can't do these on your own yet, then you still have practice to do. You need to master this so that you can get, a good score on the next quiz and test. Thanks for watching.